Hi everyone, and welcome to our video on the domain of logs. So a log function has an argument, which I labeled here as an x expression, that must be greater than 0 for its domain. So that's all we have to verify. That's all we have to make sure that stays true. So for instance, when finding the domain of these functions, what I want to do is just make sure that this expression right here, the x plus 5, stays greater than 0. And then we would solve it like normal, so like subtract the 5 over. So x would be greater than negative 5. And then from here, I would draw just a quick number line. The greater than symbol means you would use an open dot on the negative 5. And then x being greater than negative 5 would be everything to the right. And so this gives the visual of the answer, parentheses, negative 5, comma, all the way to the right forever, which would be an infinity symbol. Let me try that one more time. Like that. Okay, so negative 5 to infinity is the domain. So what it's saying is you can plug in anything greater than negative 5 into this x, and it will give you some number. Okay, so but if you plugged in negative 5 or less, you would get an undefined. So it wouldn't give you an actual number. Okay, so moving on, number 2. Notice this part is a polynomial, so this doesn't matter to us in the domain because polynomials domains are all real numbers anyway. So that means really all I care about is still just what's inside the log. So the 2x minus 7 needs to stay greater than 0. And then we'll go about it and solve it the same strategy that we did before. I can add the 7 over, and then I could divide by 2. So we got x is greater than 7/2. And then from there, again, I would just draw a real quick number line of the one value that's important, open dot, x being greater than 7/2 would be everything to the right. So 7/2, comma, infinity is our final answer for the domain of this problem. Okay, so let me move that blinker. There we go. Okay, so moving on, number 3. Number 3, we have a log again. So it's log base 5 of 5 minus 6x. So still, if I'm just finding the domain, I just need to make sure that that expression is greater than 0. Okay, and then solving it like normal, I would subtract the 5 to get this. However, solving it like normal is still the same procedure, except remember, if you divide or multiply by a negative number in inequalities, that the inequality symbol needs to change its directions. So this greater than will become less than. Okay, so that happens whenever we multiply or divide by a negative. So let's say inequality symbol changes directions when multiplying or dividing by a negative. Okay, so there we multiplied, or we divided actually, sorry, both sides by negative 6. Okay, so anyway, so the x is still there though, and then the greater than became less than. Negative 5 divided by negative 6 would be positive 5/6, like that. Okay, so that's kind of our informal answer. And then just like I did on the previous problems, I would get that quick visual. So an open dot on the 5/6, but this time it's everything less than 5/6, so that would be everything to the left. Okay, so for our final answer then, reading this left to right would be negative infinity to 5/6, both with parentheses. Okay, so open dots always get parentheses. Infinities always also get parentheses. Okay, number 4 gives us a log function and a rational function. So here we have to make sure we do apply both rules. Log domain rule is to make sure that that argument there stays greater than 0. Okay, so that one's nice. Let me mark it number 1. That's what we just did. And then let me put this one to the side in the purple. Number 2, we have a denominator. So this thing right here, this is our rule number 2. Denominators cannot be 0. Okay, so that means that x squared minus 144 cannot be 0. And then from here, we could solve it however way we want to solve it. I would just do x minus 12 times x plus 12, so I'm going to factor. And then from there, I can solve by setting each factor not equal to 0. And so completely solving it, x would not be 12. X would not be negative 12. Okay, so these are also involved. Okay, so I'm kind of clouding what we currently have. And then what I want to do is put this information on a number line. So here's where the number line really pays off. All right, so I have 0, I have negative 12, and I have positive 12. So those were the three important values. And then I'm going to plot them the way that I did those previous style problems, at least this part in the blue. X being greater than 0 would be this portion. And then in the purple, I can't have negative 12 or 12, but I would have been able to have everything else. Okay, so I'm plotting them both individually on this same number line. And then our answer, though, is where the two are in common. Okay, so they're both in common, starting at 0. So they both become in common. Let me put that down below. 0, and an open dot is what is the main symbol there. So we use an open dot. And then it goes to the right until we get to 12, and then we have another open dot. And then it goes to the right again forever. Okay, so the answer is the overlap of the two individual number lines there above. Okay, so and we use open dots over anything else. Okay, so notice again, there's nothing in common until we get to here. I'm going to put a parenthesis. And then at 12, we needed to make sure that they were in common with an open dot. Okay, so anyway, so that's how we break these ones down. Okay, so reading this left to right, I would have 0, 12, parenthesis at 12, and then a union symbol, 12 to infinity for our final answer. Okay, and so that's our final answer for this. This is what goes in, or what can go into this function. So anything less than 0 would not work because of the top part being a log. And then 12 on its own would not work because 12 squared minus 144 is 0, and you can't have that in the denominator. All right, but that's that. Okay, so this fourth one is as tricky as it gets. I would just recommend always making that number line. But other than that, remember that the domain of a log expression is just making sure whatever the argument is stays greater than 0. Okay, so that's it. Thanks for watching. If you have questions, let me know. Otherwise, I'll see you again soon.